Okay, in this video, we are going to show on how to create conceptual models. We'll focus on 3 examples, and we'll also talk about a small case that we see here. So these examples are actually small case studies, and we will develop these models based on the information that is provided in the case. The purpose of these models is to show the business domain, that what exactly happens in the business. The first case that we take is what you see right here about a situation where a professor teaches certain courses and okay. So yeah, we are talking about this particular scenario where a professor teaches a course or a class, and students takes a class, and there are some cardinality restraints, as we can see here. Now, we are not going to create different kinds of entities and put them separately. Rather, we have to come with one single model where all the entities are connected somehow. Okay, so we will first start with talking about the entities, and I have used Microsoft Visio to draw this. So let me show you how I came up with this solution, and I'll discuss it one at a time. The first thing that I note here that we talked about, there are 3 kinds of entities: professor, class, and students. So we define this by adding the relationship called teaches. So the way we read it is from left to right. So professor teaches class, class is enrolled by student. So okay, so let's continue with the example that we were talking about, professor teaching a class. So we identified there are 3 entities here: professor, class, and student, and we talked about how do we read the model from left to right. We identified that there are 2 relations among these 3 entities, so teaches and enrolled by. And I also have spoken this before in the class that we should not connect professor and student because we are able to infer the same relationship through the class. The less relationship we can use, the better it is in order to model the domain. So this one is pretty simple. Professor teaches class, class is enrolled by students. But one thing you note that the description also talks about different kinds of cardinalities. So we need to put cardinalities right here, right here, right here, and right here. And all these cardinalities are been explained or provided, that information is provided in the description. Also to note that I haven't included any attributes here because the description did not provide me any list of attributes. But if I want, I can add certain attributes such as employee ID, name, date of hire, class would be class ID, class name, number of, class name, location. Student will be student ID, student name, and things like that. So let's see how I continue developing it to create the cardinalities into this model. Now, one thing I would tell you that we will use the minimum maximum cardinalities, which is we can use up to 0 to n. So it could be 0 or 1 or n to the maximum. So we'll put a cardinalities in bracket here and bracket here to show the relationship between this and this. If I put a cardinality right here, it will show the cardinality about the professor. So if I write a cardinality here, it will talk about the class that the professor teaches. If I write a cardinality right here, it will talk about the class that students take. If I write a cardinality here, it will talk about the cardinality restraints by the students. So let's see what it looks like when we put the cardinalities. So here I have added the cardinalities here. It says that one and only one professor can teach a class, which means the minimum number of professors that can teach a class is 1, so is the maximum. So I use 1 and 1 right here next to the professor. I don't use it here because if I use it here, it will talk about the cardinalities about the professor. Rather, it says 0 and 3. 0 is optional. That means a professor may not teach any class. but maximum classes that a professor can teach is 3, not more than that. Now why? Because this is the rule that has been provided in the description. So this is clear, 1 to 1, and 1 and only 1, maximum 1, minimum 0, maximum 3. So we have talked about the cardinalities of this part of the model. Let's focus on the cardinality of this part of the model. It says that student can take up to 5 classes and minimum 1 classes. So because we're talking about student and the classes, number of classes, so we write it just next to class, 1 and 5. Next, we write here 0 to 30. That means number of students that can take in a class or are enrolled in a class. Maximum is 30, minimum is 0. You might ask why 0? Now, this is just a description in the case. Generally, 0 is not put in a real world database. The constraint would be generally 1 or 3 or 5, whatever the business rule is. So if I put 0 here, that means I can have a class table, I can have a student table, but I can leave everything blank in the student table and there's not a problem. So 0 is just optional. That means there can be a situation, there is a class, the enrollment is there, it has been declared, but there is no student. So this is just a possibility that student can, there could be 0 student. But the rule is 30, so not more than 30 students can take part in the class. Now this is Visio. I don't have to use a Visio to create this model because I am not linking this model to a database. So if you are focusing on analytics, you really don't have to focus on this particular Visio or any other tool. You can use simply Microsoft PowerPoint, or you can actually draw it on hand, because the whole purpose is to understand the domain that we are talking about. So this is the solution for the situation of professor. Now let's move to the next situation, where is a DVD or a video rental case that we discussed in the class. So in this particular case, you see that you have been provided with a situation where video has to be rented by somebody, and the whole purpose of this is there are two purposes. As first is to model the business so that the person who is managing this would be able to understand what are the key concepts in this business. And the second important focus of this is to show how. Okay, so let's continue with the discussion of the video rental case. So the first thing that we will do is try to list the possible entities that we can identify in this case. And here is a list that I have drawn, written here: rental, movie, customer, store, VHS, and DVD. Now these are just the names that I just popped in my mind, and so I just wrote them, and I will now analyze whether all of them are relevant or some of them are relevant. So I would first start by saying that, okay, maybe there is something wrong with the names that we see here. So let's focus on the names here that we see here and say that, okay, maybe this is a better list, and we would like to delete the last 3 entities here. Rental, yes, we need to capture the rental information. We need to capture the information of movie. We need to capture the information of customer. But store is not an appropriate entity for this particular case, because we are talking about the rental operation inside a store. In other words, what are the key entities in the store operations? VHS and DVD are actually kinds of formats of movies, so they are not probably good entities in this particular case. But remember, if I say no, it doesn't mean that in some other case DVD cannot be an entity. Yes, it could be an entity, but in this particular case, DVD is not an appropriate entity. Next, I'm going to talk about one more important thing, is we need to distinguish between the concept of movie and the physical device where the movie is stored. And these are two different things. One is intangible, which is movie. And if I want to define a movie in terms of attributes, we can talk about the title of a movie, the year of production, producer's names, director's name, actor's name, actress's name. So we are all talking about the concept of movie. Whereas if we talk about the physical device where it is stored, we can talk about it stored in a VHS, it can be stored in DVD, it can be stored in Blu-ray, and the attributes of this physical DVD could be what is the format, what format are we trying to store, and how are we going to store it, how many copies of this device we might have, things like that. Now, why is this distinction important here? It is very important here because we don't rent the concept of movie. We don't rent it. The rental is about the physical device. So the owner doesn't make money by renting the concept of the movie. In fact, the owner has no ownership of the concept of the movie. The owners only own the physical device, and only the physical device could be rented. So that's why the device is very important to be added here, here in this particular case. So the way we would capture this device, we'll call it as a generic name as video. We are not going to call it as VHS or DVD. We'll just call it as video. So we will have a new entity called video apart from movie. So right now we have rental, we have movie, we will add video. So we have done that, and within video we will have formats, and in the formats we can store either VHS or DVD as we can. Now we also have to understand that each format might have multiple copies. So now we can introduce the concept of copy as an entity, and one of the most important thing about this is the status, which means as an owner I would be very interested to know that what is the status of a copy of a video. Is it rented out or is it inside the store? So when we say status, the attribute, the value could be yes or no. Yes could mean it is inside the store, no could be it is out of the store. So you have seen that I have introduced copy as an entity, I've introduced video as an entity. So I'm going to write rental, movie, video, customer, and copy. And finally, I'm going to introduce the concept of a member as a subtype of customer. So why do I do that? The reason is, just consider that you are walking into a video store for rental. Now anybody who walks into the store, that person is not allowed to rent it. In other words, there is a condition to rent it. The condition is you have to be a member, you have to submit your credit card number. Once we do that, we will name that entity as member. So rental, movie, video, customer, and member. But member is a type of customer. What do you mean by type? That means anybody who walks in is a potential customer, we can call that, but only members are those who can rent the customer. So member is basically who rent a video. So member is basically a subtype of customer. So all what you see which are highlighted here, these are the entities that will end up in the solution. Okay, so let's now see the solution. So first we will talk about a basic solution, and then we'll modify it and make it a permanent solution. Again, I have drawn it in Visio, but you can do it in hand or use PowerPoint or a Word file, whichever you might feel comfortable. So movie has title and date of release. So we are talking about the concept of movie here, and this is the physical method of storing, which we call it as DVD. And we have three things here: format, number of copies, and status. So format is something that is important, what format it is, number of copies, how many copies we have, and status, whether in or out. Rental, again, it's a kind of a relationship that has its own attributes. So we will write them out, and as we talked about, okay, this is wrong, the arrow should be the other way. So member is a type of a customer. That's what you see here. Member is a type of a customer. So member will have all the information here, name, address, plus all this that you see here, credit card number, data membership, and stuff like that. Now let's look into the modified solution here, where I have added copy, and this is the actual solution of this. Now you notice here the status of as an attribute was appearing here. But that is actually incorrect because each copy might have multiple status. So how will I keep track of each copy? So I need to create a different table, or an entity called copy, and inside it I will use the attribute called status. So now I have a format and number of copies. So I know for each video what is the format, DVD, or and for each format how many copies we have, and then we have as copy the status of each copy. We can further divide this table into some other way so that we can keep track of how many copies are there for each of the format. Okay, we don't need to do that at this stage, so we'll just leave it here, because if we do further, it will be more of a database implementation. So we'll leave it here where we have enough information to collect, to know or to analyze, how many copies of a particular format we have here, what is the status of that particular copy, when it was rented it out, what was the rate that it was rented out, when is the anticipated date of return, who are the members who have the details of who can potentially rent. Now, just imagine, the reason I'm talking or calling this as a conceptual model is because if I show it to the owner will have a good understanding of what is going on in the business in terms of the attributes, in terms of how this is modeled, in terms of the main concepts. It doesn't talk about the process. It doesn't talk about how a member becomes how a customer becomes a member, or how a member actually rents a video, or how many copies, or how to decide what are the copies or number of copies or number of formats we need to order. But it talks about these, in other words, this model will invoke these questions that I asked just now. And the answer to these questions are actually the answer of analytics later. So using this, business owner might be interested and ask questions such as some basic questions about the operations. How do I know what are the status of which copy or copies or formats? Or in future, if a new movie is released, then how many formats and how many copies should I order? To answer that, the owner has to give that job to an analyst, business analyst, and the business analyst will run different kinds of data analysis and tell that, okay, if such and such is the title, then it is good to order this many type of formats, which each having at least this number of copies. Just imagine the powerful information that has been provided and how valuable it will be if such kind of information is available to the owner. So this concludes the second example of the video rental. Now we will proceed to the next example about a bank operation. Okay, so let's now focus on how do we create a conceptual model for the Mighty Bank case. It's a simple case of deposit of some money. Here is the description, and you can see there are quite a few possible entities, and the first task is just to list them down. So let's see that what are the possible list of entities that we can come up with. Here is a possible list of entities that you can see here. Now, again, this is just a possible list, and we can easily eliminate some of them, and we'll discuss some of them in more details. First is, we are talking about an operation of a bank, the main concepts inside the bank, so we'll eliminate this. There is, it's not that we cannot model bank or the name of the organization, at least not in this case, but we can do that in other cases where we are different scenarios, such as multiple banks in multiple locations, and you want to see how different transactions take place in multiple places. There, the notion of bank might be important to capture. So bank is not something that we'd be interested in. Similarly, Carol and Jack, we know that they're different. These are the names of tellers. So basically, these are actually instances of tellers, so we have to ignore them. Deposit is an important concept because basically we are managing the deposit. Transaction, that's important. What about check? Check is a type of deposit, so probably it is not suitable for to be a candidate as of an entity. So we can deposit, we can delete that. Customer account, um, customer account. We'll see. Okay, we'll talk about that a little bit later. Deposit slip. Now, deposit slip is actually a piece of paper. Now, it really doesn't make sense to capture it as an entity because, again, the importance of it is not the physical paper, the physical deposit slip, but what is written on the deposit slip. Now, what is written on the deposit slip is basically the information of transactions and deposits. So really, we don't need anything of deposit slip. We'll need customer service because that is an important entity in this particular case. So let's just focus on these concepts once more and see that why we are not able to model some of them. So we see that deposit slip is not important, which we just said. Check is a type of deposit. Jack and Carol are instance of tellers. Now we also note that there are two types of tellers who have different responsibilities. So we need to introduce the subtyping of tellers. And we are modeling the key entities of certain aspect of bank, which is kick deposits, so should not use bank as an entity. So this list, these are the reasons that why we should omit some of the entities that we just talked about. So here is our final list of entities: teller, teller 1 and teller 2. Teller 1 and teller 2 are subtypes of teller. We use the word fund instead of deposit. I'm going to talk about that in a minute. Transaction, customer account, and customer service. We need to model teller 1 and teller 2 as subtypes of teller, but as you recall that if we want to model something as a subtype, then we must have one additional attribute in each subtype that is different from the supertype. Okay, so we now move to the actual model here. So we have done that, and let's look into the model here. This is the model that we have developed. So let's focus here that our model has customer. We all know that is important. And as I told you, that customer has fund. So instead of using the word deposit, we are actually using the word fund because we have used the word deposit here as a relation. Customer deposits to the teller. Teller, there are two types of teller. Fund has an account number, date of creation, account type. These are the possible answers. Now, customer, you see that these informations are not mentioned in the, maybe some of them are mentioned, not all of them, so we have added them. As I told you before that we need to have at least one more attribute inside the entities. If you don't, then we cannot say teller 1 is a type of a teller. Teller 2 is a type of a teller. Skills is a type of an attribute, though the information of skills was not mentioned in the case, but we just made it up to separate teller 1 from teller 2. Now, how do we model skills in a database like verification skills? We can use a pre-assigned value. For example, verification skills could be high, medium, and low. So some tellers might possess very high verification skills, whereas some tellers might possess very low verification skills. And we can capture that information in a database. So this is the solution here. Now, if we go back to the actual case, we will see something very interesting here. You will see that the information that we have here also has information of process. That means how Jack checks something, and it talks about the process of actually how the deposit takes place. Now, process or something like a flow chart is not stored in an ER model. The purpose of ER model is just to capture the concepts, not the process. So you might wonder that how can we draw a process from here, and how will it look like? The answer is yes, you can draw a process model here, and I will show you an example of a process model. But the answer is you really don't need to focus on a process model in this particular case. So let me show you the process model first, and then I will come back and answer another issue. So in this example, you see a process model. it talks about the flow of the business, exactly what happened, the sequence. You can see that customer decides to deposit. It starts with the customer, fills up the deposit slip, then it goes to the teller one. Teller one does a verification. Either the teller one sends to the customer service, or it goes to ask to do some other stuff. Then from there, teller two takes into charge, and something happens, and finally it goes back to the customer. Well, I'm not going to explain the details of the process model, but you can see that there is some kind of flow of information that is happening here. This, as you see, even the concept of deposit slip, or check details or accounts, some of these concepts appears, receipt appears. But these concepts do not appear in the ER model because the process is not important there. The focus is only on the concepts. So this is like a trade-off, that either we draw a process model, something like this, to show how things flow in the business, or we draw the ER model to show the main concepts. For analytics and analyzing the data, ER model is much more important than the process model. Now, we are not going to use process model in this course, but then a question could be that why do we have process model? Process models are important because process models tells us a lot about the business, how it actually works. And if you can see, if I just move lines from here and there, I can change the business process. And that has a lot of implication in how a business operates. So process models are important. Okay, so we separated process model from this. Now, if you go back to the case, you see that we have one more information here. This is about a rule. The rule is out of state or post-dated or past-dated checks should not be accepted, or it should not be accepted. It can only accept checks which are current. So anything that is out will not be accepted. Now, how do we include this in our ER model? Because if we look into our ER model, we don't have any information about the check deposit. First of all, we don't have an information called check. It is under this type. One of the type of fund is called as a check. So answer to that is the scope of this is not to capture the constraints. So ER model also has something called constraints that can be captured, but we didn't go far in that detail. So they will be not used in this model in this way, but they would be used as an implementation feature. So not in the database model, but used as an implementation feature. I'll show you an example of that. So if you read this couple of lines where there is a case study, it shows to how to model constraints. It says that, okay, if you see certain value on one entity, then go and do some other checking on another entity. Okay, so if you found some information on account entity, then do a check on the account details as well. So this is kind of a rule. This rule is classified as a constraint. So same rule we have in this particular case. And the rule is pretty simple. If somebody deposits a check, verify it whether the check is outstation or not. Now, so we come back to the scope of the model. First of all, constraints cannot be modeled directly inside the conceptual model. We have to do it more as a statement. As you see here as a statement, it is not easy to show them. That's what it says. Showing this type of specific condition on ER diagram is difficult. That's what it says here. So showing this type of conditions are not easy. It's generally we try to avoid that here. So it is these kind of constraints are actually used as an implementation, unless there is one situation where you want to keep track of how many checks that have been deposited are outstationed. But anyway, you are keeping track of only the checks which are not outstationed. So if the focus of database is about collecting information about old checks, out of station checks and other kind, then we have to come up with an entity and define it and relate it to something with check. But we don't have that information here because we don't need it here, because we treat that as a constraint and we will not include that in the model. So we provided three examples in this particular case. One was the professor ER model. The second one was the third one is Mighty Bank. and the second one was the video rental. In all three, we created these three ER models when we call them as conceptual model. The focus of these models is to just highlight the key concepts which we termed as identities and how they're related to each other. And further, we will use this to analyze the data later. The focus is more on the business aspects, not on the database, though these models can be developed as data models and database. That's a separate concept altogether. The focus of this is not to talk about the sequence, not to talk about the process or flows, so we don't include them, not to show the constraints, just to focus on the main concepts of the domain.